In previous lecture, we were doing machine control group of instructions, which is further grouped into three types: stack operations, interrupt control operations, machine control general operations. So we are done with stack operations and we had started with interrupt control operations. So in interrupt control operations, the instructions are used to deal with interrupts. The instructions which are used to deal with interrupts falls under interrupt control operations. So the interrupts which falls under this group are sim instruction, rim instruction, and enable interrupt instruction. There is disable interrupt instruction also, which is not mentioned here. So let us do these three interrupts which are mentioned in interrupt control operations. So we had an overview of sim instruction and rim instruction in the previous lecture. We were trying to understand each bit of the accumulator. What each bit means in an accumulator when we deal with sim instruction. Sim instruction, set interrupt mask. Set interrupt mask is used to give the serial output. It is used to mask the interrupts. The interrupts RST 7.5, 6.5 and 5.5. These are the hardware interrupts. Also, set interrupt mask is used to reset the pending RST 7.5 interrupt. So we were already done with the bit D7, D6, D5 and D4 we will understand in detail when we will be learning read interrupt mask. That is rim instruction. So this D4th bit, the RST 7.5, when this bit is represented as pending, when this bit is 1, then it is reset in set interrupt mask. It makes it 0. So when we will learn read interrupt mask in detail, then this bit will be much clearer to us. So this is the word file which we were following. Now there is a D3 bit. This D3rd bit is mask set enable. If it is 0, then what it means, when it is 1, what it means, that we will learn in D3 bit. Mask set enable. When mask set enable is 1, then these three lower bits, this bit will be either masked or unmasked. If this bit is 1, then these three bits will be either masked or unmasked. If this bit is 0, then these bits have no meaning. These bits are not used. It means when this is 0, that means sim instruction is not used for masking or unmasking. So let's see what's written here. Bit D3, mask set enable is like SDE. It is like SDE. This SDE bit, when it is 1, then the bit at D7th position will be given as output. If this is 0, then this bit will be ignored. This means that the D7th, when this is 0, then the D7th bit will not be sent as an output. So this MSE is somewhat related to SDE. SDE is 1, then SOD is sent as an output. When MSE is 1, then these three bits have some meaning. When this is 0, these bits have no meaning. So that's why it is written that it is like SDE. It indicates whether the lower 3 bits, these lower 3 bits from D2 to D0 are ignored or not. This allows the serial data output to occur without affecting the interrupt masks. So if there is serial data output happening and this MSC tells this MSC will deal with interrupts and SDE will deal with serial output data. So it prevents the interference with serial output. That's what it is trying to say. This allows the serial data output to occur without affecting the interrupt masks. If a sim is executed with this bit low, if this instruction, sim instruction is executed with this bit low, which is 0, the condition of the mask will not change. If a sim is executed with this bit set high, the mask bits will set according to the lower 3 bits of the accumulator. Now what it's trying to say is when this is 0, these 3 bits have no meaning. Let it be 0, let it be 1, it has no meaning. But when this is 1, then these bits have meaning. So what exactly is happening when you execute the sim instruction? Set interrupt mask. When you execute this sim instruction do not have any operands. So when you execute this sim instruction, the contents of the accumulator will be predefined. The contents of the accumulator will be predefined. When this sim instruction is used, the contents of accumulator is predefined, which means that when the programmer wants to use the sim instruction is used to serially output the data and to mask or unmask the interrupts. So which interrupts you want to mask, which interrupts you want to unmask will be determined by the sim instruction. The programmer can control the interrupts using the sim instruction. The programmer can decide which interrupts should be masked, which interrupts should be given service, which interrupt should be ignored, and which interrupt should be given service. So since this sim instruction uses the contents of accumulator, so there is some value in accumulator, for example A3. So when you will convert it into binary, so this is the binary of A3 hex value. So this is D0, D1, D2, D3, D4, D5, D6, D7. So this bit will determine whether the D7th bit should be given as output or not. So it is 0, that means this bit will not be given as output. D5th bit is not used. D4th bit is a pending RST 7.5. RST 7.5 is an interrupt. So it is, if it is pending, if it is 1, it will be reset. It will be made 0. But since it is 0, nothing will happen to this. If this would have been 1, it would have been resetted. It would have been reset to 0. Now D3 bit. This is MSE bit. Mask set enable. This is 0. That means these bits have no meaning. If this would have been 1, this would have been 1, then these bits will have meaning. Which means if this is 0, that means this interrupt is enabled. 7.5 is enabled. If this is 1, that means 6.5 is disabled. It is ignored. If this is 1, then 5.5 is ignored. So depending on what programmer wants. Does the programmer wants to ignore the RST 6.5 and RST 5.5? Does the programmer wants to unmask, or does the programmer wants to give service to the interrupt 7.5? So the programmer will decide the contents of accumulator beforehand. Okay, since this is 0, then these bits will have no meaning. So here these bits have no meaning. Same instruction will not be used for masking or unmasking the interrupts. Even this instruction will not be used to serially output the data. So if you want to use the sim instruction to deal with masking and unmasking the interrupts, this should be 1. So you should decide the respective bit pattern. Like I want to have AA. So when I will convert this into binary, what I will get? This is the binary which I am going to get. This is D0, D1, D2, D3. So if D3 is 1, that is mask set enable is 1, that means these bits have some meaning. These bits will be used for masking and unmasking the interrupts. So D2 is 0, that means this is enabled. That means it will be serviced by the microprocessor. If this is 1, this is masked. It is ignored. The microprocessor will not provide service to this interrupt. It is ignored. This is 0, that means it is enabled. The processor will service this interrupt, and it will interrupt based on the priority. RST 7.5 have higher priority as compared to RST 5.5. So if the programmer wants to deal with interrupts, if the programmer wants to mask and unmask the interrupts, the programmer should use the same instruction. Next is bit D2 to D0. Bit D2 to D0 is what, let's see what's written. RST 7.5, RST 5.5, RST 6.5, RST 5.5. These are the interrupt masks for 8085 interrupt 7.5, 6.5, 5.5. If the corresponding bit is 0, the interrupt is enabled. If the bit is 1, the interrupt is masked. That's what I have told you here, that if this bit D2, which is 7.5, RST 7.5 is 0, that means it's enabled. If this is 1, it will be disabled. This will be ignored. Then we'll talk about rim instruction. Rim instruction is used to read the interrupt mask. Set instruction, sim instruction is used to set the interrupts, make the interrupts maskable or non-maskable. Set interrupts is used to mask the interrupts or unmask the interrupt by deciding the bit pattern of the accumulator. But rim instruction reads the contents of accumulator. It is only used to read the contents of the accumulator. Also, rim instruction is used to read the data bit by bit using the SID pin, serial input data pin of 8085 microprocessor. So this rim instruction is used to read and only read. Set instruction is used to set the interrupts 7.5, 6.5 and 5.5. Read interrupt mask is only used to read the interrupts and also read the data bit by bit. So let's see what's there in rim instruction. This is also single byte instruction, which is used for reading interrupt masking information as well as serial data input. So rim instruction is used to perform two functions. It utilizes accumulator contents for that purpose. It will read the contents of accumulator to read the information related to interrupts and also to read the data bit by bit through the pin SID. The significance of accumulator contents is as follows. Here's the diagram. And as you can see, this rim instruction do not have any operand. So let us see what each bit of the accumulator mean when we use rim instruction. If programmer wants to read the contents of the accumulator, read the interrupts, read the data serially from SID pin, the programmer will use the rim instruction. So let's see what each bit means in rim instruction. So when we talk about bit D7, this is the input pin of the serial data interface, which is connected to pin 5 of the 8085 microprocessor. In 8085 pin diagram, when you will see the pin number 5 is SID, serially input the data. So it is used to read the contents from that pin and store it in the D7th bit. Then we will talk about bit D6 to D4. Bits D6 to D4. These bits indicate that an interrupt is pending for these three 8085 interrupts, 7.5, 6.5 and 5.5. These bits indicates whether these bits are pending to be serviced by the microprocessor or not. If these are 1, that means it is pending. If these are 0, that means it is not pending. So depending on the contents of the accumulator, it will tell us whether these bits are whether these interrupts are pending or not. So if interrupt 5.5 or 6.5 have been masked off means ignored by bits D0 to D1. If these interrupts are being masked off or ignored by bits D0 or D1, bits D4 and D5 will not be set. If these bits are if these bits D0 and D1 are masked off, are ignored, then these will be 0. These bits will be 0. 6.5 and 5.5 will be 0. Will not be set means it will be 0. Bit D6, when we talk about bit 6, which corresponds to 7.5 interrupt, RST 7.5 interrupt, it will be 1 even if this D2 bit is ignored. Even if it is ignored, this will be 1. It will show pending even if it is ignored. So bit D6, which corresponds to the 7.5 interrupt, will be set on to indicate that interrupt 7.5 was requested even if it was masked off. So this indicates that 7.5 interrupt was requested even if the processor ignores it, masks it off. So this pending bit, even if it is ignored, this bit will still be 1, which shows pending. So I had told you while doing the sim instruction that D4th bit depends on the D6th bit when we talk about rim instruction. If this bit is pending, it will reset it will be reset using the sim instruction. Even if the interrupt 7.5 has been masked off, it still shows that it is pending, and it will be masked off while using the sim instruction. Using the sim instruction, we can make it 0. Then we will talk about D3 bit. This D3 bit, before rim instruction, if we use enable interrupt, if we use enable interrupt instruction, this enable interrupt instruction is used to enable all the interrupts of 8085 microprocessor, that is RST 7.5, 6.5, 5.5, all the interrupts will be enabled. So when interrupt enable instruction is used somewhere before rim instruction, then this bit will be 1. This bit will be 1. If interrupt enable instruction is used before the rim instruction, then this bit will be 1. If disable interrupt, which is DI instruction, is used somewhere before the rim instruction, then this bit will be 0. Now we talk about, okay, let's see what's written here in bit D3. This bit indicates whether the interrupts are enabled using the EI instruction or disabled using the DI instruction. Now we will talk about bits at D2 to D0. Now we will talk about bits at D2 to D0. This corresponds to the bits of sim instruction which we had learned from D2 to D0. If it is 0, that means this interrupt is enabled. The microprocessor will service this interrupt. If this is 1, then this will be ignored. This is masked off. This is ignored. Same goes with this also. If this is 0, that means these interrupts are enabled. If this is 1, these bits are ignored. And we know that even if this RST 7.5 is ignored, even if it is ignored, then also this will be shown as pending. To reset it, to make it 0, sim instruction the programmer can use a sim instruction to reset this. So this was all about rim and sim instructions. So the rim and sim instructions are typically used to either output to or input from 8085 serial interface, or enable, disable, read the interrupt mask for the interrupt 7.5, 6.5, 5.5. So if when we talk about rim instruction, before rim instruction, if interrupt enable instruction is used before rim instruction, also assume that in accumulator some value is stored. So when we convert this into binary, what we get? We'll get this. So 1 will be serially input from the serial interface. This will be the input. The rim instruction will read the input through the pin SID. This, and this. This indicates these two bits. This is for 6.5, this is for 5.5, and this is for 7.5 interrupt. So if these two bits are 00, that means these bits are been masked off. These bits are ignored. If these two bits are ignored, then these bits are set to 0. If these bits are not ignored, if these bits are not masked, then these bits are 1. Even if this bit is ignored, then also this will be shown as pending. So actually rem instruction reads the contents of the accumulator. If you want to read the information about the interrupts, and if you want to read the contents at the serial interface, or if you want to read the bit at the pin SID, rem instruction will be used. This bit tells whether interrupt enable instruction was used before rem instruction. So if it is 1, that means interrupt enable instruction was used. If it is 0, then it will indicate that DI instruction was used, disable interrupts. All the interrupts will be disabled. All the interrupts will become 1 when these bits are 1, that means the interrupt 7.5, 6.5 and 5.5 are being ignored. When these bits are 0, that means these interrupts are being enabled. Okay, so if EI instruction is before rem instruction, then this bit is 1. When DI instruction is used before rem instruction, then this bit is 0. This is D0th bit, D1, D2, D3, D4, D5, D6, D7. Okay, so here 1 indicates that this 7.5 interrupt is being masked off or ignored. Here 1 indicates that 6.5 is being masked off, ignored. Here D0th bit indicates that this is enabled. It is 0, that means it is enabled. So what should be these 3 bits? If this is enabled, then this should be 1. And if this bit is ignored, that means it should be 0. Even if this 7.5 bit is being ignored, it will still be shown as pending. It will still be shown as 1. So the contents of accumulator should be 8, 4 plus 1. 8 plus 4, 12, 12 plus 1, 13. So it should be DE. So this is what the meaning of these bits mean, okay, in rem instruction and sem instruction. The difference between rem instruction and sem instruction is used to set the interrupts or are used to mask the interrupts or unmask the interrupts. Read is only used to read. With sem instruction, the programmer can control the interrupts. With rem instruction, the programmer can only read the information related to the interrupt. So this was all about sem instruction and rem instruction. There is an analogy of understanding the sem instruction. The analogy is something like this. Here, let us assume the process required to enable the interrupt. When we talk about MSE bit, the process required to enable the interrupt 7.5, 6.5 and 5.5 can be linked to a switchboard controlling 3 telephone extensions in a company. So there is a switchboard which is controlling the 3 telephones extensions. So let us assume the phone extensions are assigned to President 7.5, Vice President 6.5 and the Manager 5.5. So President has the highest priority, then the Vice President has the next priority, little lower than the President, and the Manager is little lower than the Vice President. Okay, so these three telephones extensions, one of the is with the President, or the President you can relate it to RST 7.5, the Vice President you can relate it to RST 6.5, and the Manager you can relate it to 5.5 in that priority, and are monitored by their receptionist according to the instructions given. So these telephone extension which is given to a President, Vice President and the Manager. So these telephone calls which are coming to the respective executive will be monitored by the receptionist. So receptionist will be monitoring which calls should be transferred to the respective executive, whether the phone call received by the receptionist for the President should be forwarded to the President or not. Will the President ignore it, or will the President will accept the call? All these instructions, whether the President will ignore it or will the President will accept the call, this instruction will be given by the President. Or will the Vice President will accept the call, or will the Vice President will ignore the call? These instructions will be given by the Vice President. Whether the Manager will accept the call or the Manager will ignore the call, this instruction will be given by the Manager. Maybe the President is in the office, or maybe the President is busy with some other work, so he cannot attend the call. So President will ignore it. Likewise, the same scenario goes with the Vice President and the Manager. So receptionist is acting as a MSE bit, mask set enable. So receptionist is acting as a mask set enable pin. Or you can say that receptionist is busy with some other work and receptionist is not currently present to forward the call to the President or Vice President or the Manager. So it will automatically be directed to the President, the call will be automatically directed to the President, Vice President and the Manager. Receptionist is not there. That means MSE is 0. MSE is 0. So these bits have no use. These instructions have no use. The instructions given to the receptionist is of no use. When receptionist is there, then the instructions given to the receptionist are in use. If receptionist is present, that means when MSE is 1, then these bits are useful. These instructions, you can relate these bits to instructions given by the President, Vice President and the President, Vice President and the Manager. Then only these bits will have some meaning. If this is when receptionist is present, then only these bits will have meaning. So when MSE is 1, then these bits will have some meaning. When MSE is 0, then there is no use of these bits because receptionist is absent. So the calls will be directly sent to the respective executive. So this is the analogy used here. The protocols of placing a telephone call to one of the executive and of interrupting the microprocessor using RST 7.6.5 and 5.5 can be compared. How it can be compared? It is given here. Okay. The switchboard is functional and all telephone lines are open. That means interrupt enable instruction is used, which has enabled all the interrupts. The interrupt process is enabled. The instruction EI sets the interrupt enable flip-flop. So interrupt enabled. So interrupt is been enabled. All the interrupts are been enabled. Okay. Now next, all executives leave instructions on the receptionist desk as to whether they wish to receive any calls. So the instructions will be given to the receptionist whether the executives will receive the call or not. So when receptionist is present, that means receptionist is MSE. That means it is 1. When it is 1, then these are the instructions below this. If this 7.5 is 0, that means president is available to take the calls. The president will attend the call. And when you relate it to the microprocessor will provide service to the interrupt RST 7.5. When it is 1, that means the vice president have instructed the receptionist that vice president will not be able to attend the calls. When it is 1, that means that call will be interrupted. Similarly, when this is 1, the microprocessor will ignore RST 6.5, and same goes with this also. Okay, so that is what is represented here. All executives leave instruction on the receptionist desk as to whether they wish to receive any phone calls or not. So these are the instructions. If this is 0, that means the president is available to receive the call. If it is 1, that means the president will ignore the call. When you relate it with microprocessor, then when it is 0, then RST 7.5, the processor will give service to this interrupt RST 7.5. When it is 1, then the microprocessor will ignore it. Okay, so these are the instructions given by you can relate it with instructions given by the respective executives. This is for president, this is for vice president, this is for the manager. Okay, if bit D3 is 1, the respective interrupts are enabled according to the bits an appropriate bit pattern is loaded into the accumulator. Then the receptionist read the instructions. Receptionist, that is MSC, will read the instruction whether the respective interrupt should be given the service or should be masked, should be ignored. If bit D3 is equal to 1, the respective interrupts are enabled according to bits D2 to D0. The receptionist is on duty and sends the calls through for whoever is available. RST 7.5, 6.5 and 5.5 are being monitored. When receptionist is busy typing, phone calls can be received directly according to the previous instructions. If bit D3 is 0, bits D2 to D0 have no effect on previous conditions. No calls for the president now, call back later. Bit D4 is equal to 1. When this bit D4 is equal to 1, and this bit D4 is equal to 1, this resets RST 7.5. This we had talked about when the RST, even if RST 7.5 is been masked off, is been ignored, this D4 bit will be shown as pending. So to reset it, to ignore it, this bit will be reset, or this bit will become 0 using the sim instruction. Okay, so I hope the concept is clear to you. RIM and sim instruction concept. So RIM and sim instructions are done. We are done with RIM and sim instructions. Then we have interrupt enable. Interrupt enable is used to enable all the interrupts. This is a single byte instruction. It has no operands. On execution, interrupt enable flip-flop is set. Interrupt enable will be set. It will be 1. That means it will enable all the interrupts, and all the interrupts are enabled. No flags are affected. So this is end of the category interrupt control operations. Now the last category is general machine control operations. This is the last topic of the chapter. So we will continue in the next lecture. So for today we will stop here.